Second electricity video, looking at circuit measurements now. So there are three ways that we measure what's going on in a circuit. They have different units and different ways of measuring them. The first is the potential. That's a measure of energy. So that's how much energy the electrons have got at different parts of the circuit. And when we measure that, we actually generally measure the potential difference, which is how much energy they gain or lose at different parts. That's measured in volts. The unit is a big V, and we use a voltmeter to measure it. Or we can measure current. Current is how many electrons are flowing through the circuit. Yeah, so it's basically per unit time, how many electrons go through that point. We measure that in a unit called amperes, or amps, A-M-P-S you'll see sometimes, and it has the symbol capital A. And the final thing we can measure is the resistance, how difficult it is for the electrons to get through. Okay, so it's like this guy tightening a noose around it, making it harder, or if he loosened it, making it easier for the electrons to get through. That's measured in a unit called ohms, and it has that little symbol there, like a kind of upside down N. So, how much energy do the electrons have? If we've got a 12-volt battery, we push out 12 volts, they've got the maximum energy. Okay? We assume the wires are not resisting the electrons. Electrons can flow pretty easily through, they're not using up energy there. Okay? Now, we're passing through three spots in this circuit where energy can get used up. Each of those will use up the same amount of energy. Okay, so when we go to lamp C, it's going to lose 4 volts, because 12 divided by 3 is 4. Lamp B, it uses another 4. Lamp A, it loses another 4, until by the time it's passed out of the last lamp, it's used up all the energy, and they will flow back without any energy left. Okay? It does spread it absolutely evenly if the loads are the same. All of the energy is always used up by the time they get back to the positive, so they don't leave anything out on the circuit. We can measure that using a voltmeter, but we can't measure it directly. We've got to measure the difference in energy between 2 points. So what you'd normally do is you'd connect it in parallel, so you'd connect one wire on either side of your load, or on either side of your power pack, volt or battery, and we'd see for lamp C that we would have 12 volts on one side, 4 on the other, so we'd measure a potential difference or potential drop of 4 volts. And that same potential difference or potential drop would be seen across lamp B and across lamp A. And we can measure across the battery to see that we've got a potential drop there of 12 volts. Our current is this flow of electrons. Think of it like a river, and there's things dissolved in the water flowing along. We can't hook it up like we did the ammeter, because the current's just not going to pass through it. Why would it? Okay, so instead we need to put our measurer in the middle. We call that in series, right in the thick of it. And it measures those electrons as they go past. If we were to look at this one, and we look at the current at all points, we would see exactly the same current at all points along there, because there are the same flow of electrons going all the way around. They're losing energy as we go, but we're not losing our electrons, and they're not changing the rate at which they go. So all of those orange dots, every point, you would get exactly the same amount. Now, we could just count electrons per second with an amperes. We could use volts. We could use joules instead of volts. Why don't we? The reason really is the numbers. If we wanted to measure electrons per second, which is essentially what amps are measuring, you're going to get a huge number. Okay? If we wanted to measure a voltage in joules instead, we'll get a tiny, tiny number. So basically, volts and amps are much more convenient numbers. They give you nicer numbers which are closer to, single digits or 0.1 or 10, which is much easier to use than these massive or tiny numbers you've got there. Our final measure is resistance. So resistance is basically how hard it is to flow through. Now we're not going to look at this in a lot of detail now because later on we're going to look at Ohm's law and we're going to do some calculations involving it. But know that the more resistance there is, the harder it is for the electrons to get through.